In this video, we are going to learn about the derivation of Schrodinger's wave equation and the main topics it is based on. A wave, as you know, has a particular structure. This form or structure is called waveform. Every waveform can be described by an equation such as y equals to a sine kx. A wave, as you know, travels through a medium. So this waveform will also travel through a medium and hence the wave will vary with time. So you can write minus omega t. And now this equation becomes a wave equation. In a more general way, a particle which performs SHM in the wave can be represented in the form of two equations. First is second differential of y with time, and as the wave will move in the medium, the x is also going to vary. So the differentiation with x will also give you a similar equation. These are the general equations of a wave. The combined equation will look like this. Second differential of y with time is equal to omega square by k square second differential of y with x. Now, this is the time-based equation, and solving this equation you will get time-dependent wave equation, and this is dependent on x, so here you will get time-independent wave equation. We are more interested in finding the time-independent wave equation. So let's begin with that. Second differential of y with x is equal to minus k square y. Now, with the first step, we are going to replace y with psi. It is just a change of variable because psi is used as wave function for electron. So the equation becomes this. Now, psi varies with both position and time, so we have a partial differentiation instead of a direct differentiation, where k is equal to 2 pi by lambda. So the equation becomes second differential of psi with x is equal to minus 4 pi square by lambda square psi. This is still a wave equation, but electron has a particle nature. So to include this, we will perform this into two stages. First, we will extend the generalization to 3D, and second, we will include the particle nature by replacing lambda with h upon mv, where m and v are mass and velocity of electron. So the equation becomes this is variation of psi in space. So we can use a simple symbol for that, that is delta square, which is also called the Laplacian operator. So the equation is delta square psi is equal to minus 4 pi square m square v square psi divided by h square. Now here 4 pi h m all are constants and their values are known, but velocity of electron is not determined, and it cannot be determined because of Heisenberg's uncertainty principle. So we need to replace velocity with some other term. We know energy of electron to be minus 13.6 z square by n square electron volt for the nth orbit. This was given by Bohr model and confirmed by spectroscopy. So we are going to use the energy of electron. Now, energy is equal to kinetic energy plus potential energy. So K is equal to E minus V. That means half mv square is equals to E minus V. And so mv square is equal to 2E minus V. Substituting this value into this equation, you will get Now, everything has been taken care, just we need to rearrange this main equation, which goes like this. Now, this is essentially the Schrodinger's equation because it covers all the parts, all the topics, the wave nature of electron, the particle nature of electron, and the simple harmonic motion of electron. But we cannot solve this equation into this way, so we rearrange it into this form. Fast forwarding to the main result, you will get the Schrodinger equation. Of course, it can be shortened by taking psi common. This will give you this, and this term in bracket can be represented as h cap psi, where h cap is the Hamiltonian operator. Thank you for watching.